So hello, this is the introduction to phasor diagrams, following on from the sine wave generation for AC. So for that particular help video, we had a rotating mechanical generator that produced a sine wave in the form of voltage versus time, or it could be current versus time. So if you were to look at the graph for voltage versus time, and if it was for a resistor, so if we have a circuit, so this would be an AC circuit, and we had a resistor in the circuit only, and we looked at, if we looked between these points here, I've slide the resistor, and we looked on an oscilloscope. On here, then this is the waveform you would see, a sine wave, continuous sine wave. So this would be the waveform. So if you then looked at the current, so if we looked at the current, what you would see is a waveform for current which would be in phase with the voltage. So this here, so right on here, current is the grey. So that is I, and this one here is V. Okay, right, so if you wanted to represent this in an easier way, then we would use a phasor diagram. So this is a phasor diagram now. And what a phasor diagram, how the phasor diagram works is you have a snapshot in time. So let's have this blue represented by an arrow like this. So if we're looking at the point on here as a snapshot of time, it would represent, that would represent the voltage, and this would be in phase with it and would represent the current. So that is the current, and this is the voltage. And then that becomes easier to represent in a phasor diagram in terms of the phase differences and things like that. Okay, so that is for a resistor. If you added an inductor into that circuit, let's try and add that now. Then you would introduce a 90 degrees out of phase sine wave. And if you then drew that onto this waveform here, so the voltage across the inductor would be 90 degrees in advance of the voltage across the resistor. So that would mean that this diagram starts to get very cluttered. But in our phasor diagram, if we again took a vector representation on here, then this would look like this, and this would be 90 degrees in advance if you're going in an anti-clockwise direction as shown by the angular velocity in there. So that would be 90 degrees in advance. And this phasor diagram on the left here starts to look easier to visualize than the one on the right, because the one on the right is adding sine waves to that waveform. It gets quite cluttered. So what it makes it easier is you can then combine these vectors in a diagram form, and you can work out things like the phase angle and the resultant phase angle and differences between those voltages. Right, that's the introduction to phase diagrams. I'm going to stop that there. The next one will go into the combination of capacitor, inductor and resistor, and how you calculate the resultant voltages and phase angles.